When we graph logarithmic functions, it's important to note that the exponential function is the inverse of the log function. And vice versa. The log function is the inverse of the exponential function. So we're going to find the inverse of y equals 2 to the x and graph it. So we're first going to graph y equals 2 to the x. So y equals 2 to the x, let me do this in a nice color. Y equals 2 to the x is going to be blue. So we put a -1 in, we get 1/2. We put a 0 in, we get 1. Put a 1 in, we get 2. Put a 2 in, we get 4. Put a 3 in, we get 8. This is a parent function, so it should be very quick for you to graph at this point. If it's not, I would recommend working on those parent functions. It has an asymptote at y equals 0. So an asymptote at y equals 0. So our domain, if you remember, is of our exponential is -infinity to +infinity. Our range is 0 to infinity. Our x-intercept is none. Our y-intercept is 0, 1. And our asymptote is y equals 0. Now we're going to graph the inverse. And the inverse, let me just show you, the inverse, we flip the x and the y. So we have x equals 2 to the y, and we solve for y. In order to solve for y, we're going to have to write this in exponent or in logarithmic form. So log base 2 of x equals y, and that's the inverse. So y inverse is equal to log base 2 of x. So here we have y equals 2 to the x, and the inverse is log base 2 of x. The inverse is log base 2 of x. Now the inverse, remember, reverses your ordered pairs. So -1, 1/2, -1, 1/2 becomes 1/2, -1. 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. 3, 8 becomes 8, 3. And our logarithmic function has a vertical asymptote at x equals 0. So we have a vertical asymptote at x equals 0. That's because our domain, our argument, has to be greater than 0. X is greater than 0 is 0 to infinity. Our range goes from -infinity and it will slowly increase. So the further we go out to the right on our graph, the more we will increase. We just increase at a very, very slow rate. So you have to go very far to the right to continue going up. So I'm going to write y equals 0 right there because I erased it. That was our horizontal asymptote. Our range is -infinity to +infinity. Notice how on the inverses, the domain becomes the inverse's range, and the range becomes the inverse's domain, because your x's and y's are flipped. The x-intercept, you can see, now exists. It's 1 comma 0, which makes sense because 0 comma 1, when you flip your ordered pair, you get 1 0. I'm going to erase that now because I don't want to keep that in my notes because you might look back at that and get confused. Y-intercept is none. And the asymptote, instead of y equals 0, is x equals 0. It's a vertical asymptote, so this is vertical. So exponential functions have horizontal asymptotes, and logarithmic functions have vertical asymptotes. It's a pretty cool thing there. It's a pretty cool thing. So that's our inverses. So the exponential function and the logarithmic function are inverses of one another. They are going to be symmetrical about the line y equals x. So I'm going to show you that. It's kind of a beautiful thing. It really, really is. So when you are symmetrical about y equals x, your ordered pairs are just flipped. So 1, 2 was an ordered pair on the exponential. 2 comma 1. 2, 4 became 4, 2. And that puts you with symmetry about y equals x. Okay, we're going to practice graphing these log functions by graphing the inverse function first. So we'll be coming back in the next video and graphing the